Good morning, good morning, good morning, good morning, good morning. 11:01. 11:01 in the UK, Central UK. Okay. Central UK, okay, okay. Just catching up with the stream. We have audio. 11:01. We have audio. It's always a good thing when you got audio. Okay. So today we're doing some more finishing off. Got to the meat and potatoes of it, sort of. Anyway, without further ado, welcome to number 4 of the NeoPixel 4-button keypad, external rated. Hopefully, put a watering can over it once we've made it. Make sure there's no water ingress, and see what we can do. Right, over to the design. Let's give you the intro, and here we go. Okay, so we're back on. I think I messed up the thumbnail at the start. I gave you a picture of me instead of the thumbnail, so let's just go back a step. So we've got the meat and potatoes. So today we've got to get this PCB to sit on a shelf and finish off the support for the middle of the buttons and mounting holes, and see what space we got left on the PCB for the electronics. Okay, let's get over to these bits. And it would be if I got it over in the right place. To start with, there we go. It's all gone a bit crazy. Right then, so let's reverse build it. So let's put everything back together. There we go. Let's give you a X-ray view. See what's going on. So it's from the initial design, it's gone a bit thicker. We've still got a lot of work to do on it. Simplifying it. We've got to get something going on here. Let's go back off the... Alright, let's take the clam top off. Fixings. Too many buttons. Right, so this is what we've got here. So we don't need none of this at the minute. We need to sort this out. So let's get rid of the buttons and the tactile. That's it. And let's just hide the PCB for a second. I'm going to try to sort this out now. So we need, let's put the fixing holes in, why not? Let's go plan view. Into parallel projection and square it up. Right, we need some fixing holes. So this is 60mm from side to side. So that'll fit on a quite a small metal post. So we need some fixing holes. So what we could do is literally let's I'll tell you what we'll do is measure some stuff. So it'd be nice to have one there to there. Is that right? No. Yeah, you want to come over sort of there. Tell you what we'll do is we'll put a line in from there to there, from there to there, from there to there, and from there to there. Okay, that's our cross lines. Now if we just come from there to there, and from there to there. Okay, wherever they cross, that's where we'll put a fixing hole. Wow. Now the problem is these aren't on level ground, are they? So how can I snap to it? They're not on level ground. So I've got a problem straight away. Right, let's put a hole in. Let's imagine where it is. Okay, so it needs to be 4 mil. 4 mil enough? Yeah, so let's go 2 point. Let's go a little bit bigger. No, let's go 4 mil. No, 4.5. So let's do 2.25, 2.75. There's our fixing hole. So we want another one of them over here. Oops, what happened? Oh. Hang on a second. Okay. I want one of them. I want both of them. And we need to move it down to here. Is that about right? Looks it. Okay. Let's have a look what we've got. And obviously they're going to be up in the air and all over the place. Right. Let's put them down to the floor. So back to perspective. Let's grab them. Can we grab them? No, grab them. And bring them down to the floor. I need to go down the blue axis. On the face of the component, that's right. Okay, so we've got them there, and we need to have a look, see if we've not moved. Hang on, get our parallel projection. Are we centered? Pretty much. Okay. Right, so we're going to do that, and we're going to cut them, and we're going to select the base and then paste in place, and hopefully we can go back to parallel, well, perspective, sorry. We should be able to select individuals. Yeah, so now we need to just chisel them down. Okay. These are our holes for our screws. Now, have we got them? Are we okay? Yay! Now, they're not countersunk, are they yet? Do we need them countersunk? Not necessarily, but it's better if they are. Although there's quite a bit of gap. Do we need to countersink? No, we're not going to. In reality, we're not going to countersink. So I can countersink with a tool, but it'll be manual. So I'll leave it like that for now. Right, so we've got that bit done. So let's just save that. Let's get rid of the lines, construction lines. Okay. Now we need to sort out this middle bit here. So we've got our cable gland that comes through. Okay, right. That's weird. Right. So, what are we going to do with this? We need to have that pillar there. We need this pillar. So we need all that, but we need a way for the gland. So we've got to work out. Got to work out something here. So the shelf, we need a shelf, so we don't need an ergonomic shelf like that with all these intricacies. We need a way for the cable to come out. So the cable's got to come out at low level. So, and ideally it needs to come out from the bottom, so any water ingress doesn't go in and up. It'll be mounted like this, mounted on a post or a wall like that. So that cable gland will come in there and down, in and down, and right. Okay, so let's just find out. That's our standard view. We'll take that as our standard view, the right way up. And we'll let's amalgamate these together. So we know we want this to be our bottom. So let's get in here and turn this into something we can make easy. Okay, so we're gonna mill this out. It's easier to mill, that's the whole idea. Where did that line come from? What happened there? Hang on, undo, draw line, undo, draw line. Right, so glitch happened then, didn't it? Right, is that? Yeah, that's okay, isn't it? Yeah. Go around here and do the same over here. Oh, that's why I didn't press escape. Right, okay, so we've now got item. So the cable could come tightly in there and then, yeah, bend down and round. That'll act as a clamp as well. So let's sort this out. So we need to delete this now. Yeah, I need to delete this. That's a PCB shelf, so we need to keep that. So there's a shelf. So let's just put a shelf in here. Do we need that shelf? Hang on, let's do it differently. Right, so we've got to bring that up to there. Right, we need to close that off. So this is back up the right way. So we don't need a PCB shelf there. We need the shelf, that'll be the way out. Sort of clamp the wire between them two. We're going to lose these two. Right. So we need to extrude that up. We need to join that up with there. So we need to lose some of this geometry. We know that's 1 million. Let's just check. Or is it half a mil? So it's 1 mil. Let's just get rid of some of this stuff a minute. So we've got some room to work. Okay, and we can also get rid of this. That. That begs the question, what we've got going on here. What's going on there? Is that the underside? Have I selected the underside? No. What have I got there then? I can see straight through there. Can I? Yeah. So what on earth is on the other side? Oh. It's alright, looking at the wrong things. Right. So I don't quite know what's going on there. Okay. Let's just reverse the face. Is that going to do it? No. Reverse the face. So that's weird, isn't it? Anyway, we don't need that now, so let's get rid of this. Let's get rid of this. It'll sort itself out, won't it? No, we need that at the minute. Yeah, we need that. So we need to bring a line from here down to wherever that is. Oh, no, it needs to come level with this. Oh, it'd be nice if it was clamped round it, wouldn't it? So what about like that? No, it can't. Hang on. Oh, it's in the middle, is it? Hang on. I can get away with that, yeah. Sort of. And we got another one here to get away with that. Don't know. Right. Okay. Yeah, it's not quite right, is it? So that's our hole with a bit of space. Then we need to bring it around to clamp it in here between these bits. So we should be able to get rid of some of this now. Alright, and we can get rid, certainly, oh, that's our hole that goes all the way through, isn't it? Right, let's get rid of that hole. Okay, now this one. Right, so, oh no, we still need that hole. We're okay there, so now we want to do a shelf around it. Let's see if we can do a shelf. Can't go all that. That's not happening. Okay, let's interact. Interface sections with a model. Yeah, that'll work. Now this is a bit weird here, so we've got to get rid of that bit. So we sort of need to come up from there to sort of like that, maybe. Yeah, that's okay. Is that okay? Maybe. Maybe. Just took the wrong bit out. Okay, so we've got that. Right, that's alright. So what's the distance between these 2 points? 2.8. I can't get a 4.5mm cable in between them unless I squash it. That's a bit too fierce. Bit too fierce, so we need to sort that out. So we need sort of this. Right, so we sort of need a straight line. So somewhere like that. Yeah. Then we'll put an arc on it. No, that's not right. What about this other arc? No, that's not the one. No, that's not the one either. Right, that's the arc. Right, so it wants to go there for some reason. I need to keep this bit. Right, so, So, we need to go, I don't know. These are our old pillars. Right, so I need to do something with it. I'm not quite sure what though. Let's have a look. So unless we come down here. And Let's try that. Okay, so that's a little bit different. Right, I like that. I like that bit, so let's get rid of this. Okay, so we've got that bit there. We seem to have... yeah, we're sort of about the right angle. Okay, so we need the same again for that. So we could just as well grab it. Oops, let's just grab it. Apart from that. No, let's do it manually. One of them and that. Copy. Paste. So I'm going to paste it there. We're going to flip it. Flip along the red. We're going to grab it if it hasn't. Oh, no, it's too late. Undo, flip. I need to move it. Alright, it's not working out. Oh, so I'm pressing the wrong button. No, I'm not. I need to move it. That's it, and flip it. Flip along. Right, okay, then grab it. And push it there. Then delete this stuff. Okay. Why does that look horrible? It does, doesn't it? I don't know. Why is that looking weird? Doesn't look as good as that side. So, I don't know. Or maybe, hang on. Right, let's just do it manually. That's probably why. Okay, that's sort of like it. Yeah, not in parallel. Let's go parallel. Is that right? Yeah, looks about right, doesn't it? Okay, so we've got that. And we can select... no, we need to intersect faces with the model. Now we can select that, right. Okay, back to perspective. Right, so we've got that. Now we need a shelf. So we need a shelf. A 1mm shelf. 1mm. Right, okay. So we need a shelf for the PCB to sit on, but we don't need it to go around here. I'm just thinking that would probably fit a cable tie. Yeah. No, do we want a cable tie? Need something. So leave it like that for now, I think. Right, let's bring that centre bit up to the level of this. So let's just go for it. So we need to come up to the same level as this. Right, what's happened? Why have we got a massive great big hole here now? I wanted a nice tight fit here so we could seal it. So let's undo that. Let's sort this out first. So we literally want... let's have a look from above. Right, so I want to start from here and go straight across to wherever this is. Why is that totally out of whack? That's weird. It's nowhere near, is it? So we've got a bit of a weirdness going on there. strange. So start from there and go across. Huh. That's not good. Okay, so what can we do? What can we do? Why has it got flat script properties on it? Ah, is that why? Yeah, we didn't go to the corner properly. That's why. Yeah. So let's get rid of this bit. Let's get rid of that. Get rid of that. Put that there. And use that as a reference. And we want a curve from there to there. Is that better? Doesn't look quite right, does it? Right, let's try one of these again. 1 mil. Now draw a line from there. Okay, so we're drawing a line now. It's about right. Okay. No, it's not quite right, is it? It's too low. Alright, let's back up a bit. So this is not quite right here. So I wanted that to be the same as that. I don't think it is anymore, is it? Right, how are we going to do this? Does it matter that much? Don't know if it matters that much. Tell you what, let's just create these again. We need to go. Right, so let's just lose this. Let's lose that. Let's lose this one. Let's bring this down to level with this one. Let's join this up. Okay. So we've got a little bit less of it. Okay. We want the height there, don't we? What's happened to that? Right, so we need to back off a bit. Back off. Back off. Right, so yeah, we need to make this. No, we want that to be the same length as this. And then we'll join that to that. Okay, that's better. And we need to do the same here. Same again. Okay, can we draw a line from there to there? Yes, we can. Okay, so that's better. And let's put the step in it. 1 mil. And we don't need. Right, we need a line from there to there. We need one from there to there. I need to get rid of this. Oops. Oh, it's all separate, don't know why. Anyway, so we've got that. So we've got our sections. Right, okay. Yes. Right. That's looking better. So then we need to bring the whole thing Altering up. So we need to go up there to the same height as this. This needs to come to the same. It won't go higher. Right, let's change the idea. So let's go up to the same height as this, and bring this up to the same height as that. Okay, what have we got? Yeah. So we've got a cable hole comes in. Let's just save it, center it, right. Let's turn on the button, tactile button. Oh, that's right over a hole. Oh, that's on a PCB, that's okay. Now a button shell. Let's see if it's sitting right over the platform. Yeah, that's stable there and there. Okay. I haven't got much left for a PCB, but they get this. There's less to mill out, so you've got to mill all this out. Some nice patterns for milling. PCB, we should have enough PCB to be able to do the job. Now you're going to see that right at the top. No, you're not. It's when you put this clamshell on, it's going to be underneath. Yeah, so it's a platform for the buttons. So rest the buttons in. 3D. Okay. Yes, we've got right PCB. Got to sort of PCB out next. Make it same shape as the infill. This is a real mess now. I wonder if there's a wireframe version of this. This wireframe, it's just a mess, isn't it? Too much going on. Let's have a look, can't see. Monochrome, right, no. Right, colour that, right, edge style, right. Okay, so fixings. Okay, let's get back to it. So let's sort the PCB out next. PCB. Now it could just be a square one with a hole in it. A square one with a hole in it, but then you could see underneath the button where the PCBs ran out. So ideally we don't want to see gaps under there, do we? We want the PCB to create the aesthetic. So it's got to follow the contour of this aluminium. But am I milling all this out for no reason? Do we need it like that? Probably not. Let's see if how much space we got between there and there. 10 mil. So 10 mil, 10 mil all the way around. Yeah, 10 mil. Can we get away with any less? Well, the idea is to get away with just the minimum amount. Okay, so we want to mill out less, create it quicker if we mill out less. So does this need, can this just be, why are we milling this out? Is there a reason to mill that out? We need to get our fixing in. That's one reason. Doesn't need to be that thin. Are we gaining anything by not milling it out? Don't know. Don't know if we're gaining anything. Don't know. So we'd mill down and then mill across and then round. Yeah, we could do that. That can be milled, so can this bit. So the PCB, we need to shape the PCB. And Are we really gonna make it the same shape as it? Yeah, we need to fill it in, or doesn't gain us anything, does it? So the button, tactile button, will go somewhere like that on the PCB. You need the LED. The LED's got to shine somewhere. So, does it shine from the side or underneath off the PCB? So, plan view, we're going to have to somewhere fit an LED. Ideally it would be in the middle with the button, but we can't have both in the middle. So we're going to have the LED set off to one side. It's about the same size as that neopixel is, almost. In fact, tell you what, let's get the neopixel. Let's save this. Let's put the neopixel on, so I'm going to have to go and open some of my designs. Not that one. My SketchUp. Right, let's find something. Not sure which one. Let's just try that. No, that's not it. Bottom. That one. Alright, let's find it. Here we go. Right, these are neopixels. This is a temperature, a LiDAR with a thermal non-touch medical sensor, and a neopixel. So addressable neopixel. So let's just get a neopixel. Copy that and go back out to the keypad. And paste. Right, so we'll paste it there. Let's hide the button a minute. Right, so we've got to position that neopixel somewhere around here next to it. Right, so it's going to have to go somewhere next to it. What does it look like with a button on? I suppose it could get away with that, so that's why we need, yeah, to run some tracks and stuff. So probably PCB needs to follow this routing out. These are too sharp, so I'm gonna have to sort them out. Alright, so okay so far. Right, let's just make a new layer, neopixels. Put that into the neopixel layer. Okay. Righty-ho. I feel some sausage and eggs coming on for me lunch. Yeah, why not? So we need as much PCB we can get. We don't want sharp corners because we can't mill sharp corners out. Right, talking of sharp corners, that looks a sharp corner there. What has happened to that? That is weird, isn't it? I don't remember doing a sharp corner there. Oh, right, yeah, I do now. Yeah, so to hide the PCB, there's our round corner, so we're gonna have to correct this. So let's get our parallel projection up, right. So we're gonna have to do something here. Ain't gonna work. Right, so oh, we can mill that actually. We can mill round first, the bottom bit, and we can just mill straight across. So we can mill that out. It's not a problem. But will artificially have a sharper point. That's okay, that's alright. Right, that'll work out, because we're not going to try to mill round there. Although, yeah, no, it'll mill that bit out. That is the arc of the bottom bit. Yeah. And we're just going to mill straight across there, so we can have, that won't be a problem. Okay. Right. So we've got our neopixel. So we need what else do we need? And is that going to... Yeah, that sharp bit there doesn't matter either. That doesn't matter because it follows this bottom curve, so the same idea for that. So I don't have to worry about that. So what I need to do now is create a PCB shape. So I might as well create a new PCB because my PCB at the minute is all the wrong shape. So let's hide the neopixel and a tactile button. Let's look at it from above. Can I grab anything? Yeah, that's it. That's the shape there. That's the shape. No, it's not the shape, is it? The shape needs to be, yeah. Well, I'll do as a starter shape. So let's copy that. Right, I'll paste it in place. We'll hide the top clamshell, bottom clamshell. Right, so we've got this. This is our PCB, sort of. We've got to have it coming over here to sit on. So we need some relief. Now, hang on, is that the? Oh yeah, so we're gonna have to do something like this. Hang on. So it needs to sit over it, but not exacting enough to hold it up. So we can do. Can we do? Can't seem to grab that. Why is that? No. Oh, it does. It just doesn't highlight it. Oh no. Right, we need to sort this out. It's not quite right. So clean it up. Interface. Nothing to do there. Right. Edge attributes, flat edge, erase, repair, flatten. Right. So what's it done here? Oh my god, it's made a right mess of it, isn't it? So what is going on with this? Right, anyway, we've got to manipulate this no matter what. So, this is our PCB. We won't be creating all this lot. That'll cover the... Yeah, it needs to have that there to cover the wire up, which is the bottom clamshell. Right, so I need to raise it up a bit anyway. So let's just bring this whole thing up by 5.5 mil. 5.5 mil, and that should now be the right level. Yeah. To sit flush with that, it is. Then we need to make it thick, but we'll sort that out in a minute. So that at the minute is not sitting where it needs to sit. So I could do with a copy of... Don't want it exacting, I want it slight pullback. So we've got some work to do. This is the right shape here, but then the shelves aren't on. We can sort them out though. And we don't need these holes in it. Right, let's get rid of the holes. Don't need holes in it. Okay, I need to sort this out. So we need to create something here. Doesn't like the number of segments. Okay, so that's a hollow, so it goes round the cable. No, we don't want it round the cable. We want to hide the cable, so we want sort of like this. Right, let's measure from there to there. 5.75. What have we got here? 5.5, so not quite right. Okay, so what have we got? If we just take that, copy it, paste it, flip it, flip along, that'll do. Like that, take this away. Okay, so I've got that. PCB sits and covers the cable up. That's good. That's good. Aesthetics, keeping the aesthetics. It's too big, but let's make this the size of that, and that the size of that. So we could do that by draw a line from there to there. No, that's not quite right. Why are we not able to draw a line? Oh. So draw a line from there to there, yeah. Then we draw, can we get rid of that? Yeah. No. Just hide that a minute. Which one are we into? Hide that a minute. Right, now we need to just delete this. Yeah, that's what we need to do. Okay. So now we've got... Oh, because we're exactly the same height as that. Need to do the same this side. Okay, do the same this side then. Same this side, and we'll bring some relief to it. Let's just take that out. Sort the rest out in a minute. Or should we do it now? Do it now. Right, now this one. It's a laborious process. Let's get this done. Don't want to be on too long today. On this one, what we got? An hour already. Need to get this finished somehow. This bit. Likes to be able to mill it out. I haven't got any aluminium. I have to mill it out of polycarbonate for now. The first one made out of polycarbonate, just for testing purposes. Polycarbonate. Right, that's all that. Okay. So we need to lift the whole thing up by 0.1 of a mil. so it doesn't sit on the shelf exactly at the same height as the shelf. It has to sit on the shelf, not in the shelf. Right, so 0.1 of a mil, that'll do it. And when we put the shell back, we won't see. That's it, we can't see the shelf sticking through. Right, so we've got to sort this bit out next. So what we want is, we really want, yeah, we want this bit. That's okay at the minute, but yeah, we need this bit. We need to grab that. Can we just grab that without anything else? Let's have a look. No, we've got some other stuff. So let's try again. Like this. Have we just got the top bit? Yeah, we have. Copy. Alright, back to the PCB. Alright, paste in place. And we need to bring it down to the surface of the component. Keep going down on the face, that's it. So now we've got our outer edge of our PCB. So we should be able to get rid of this bit now. Get rid of this bit, and we've got a sharp bit there, but we can sort that out. We've got to pull back on it anyway, relieve it. Right, so that's that. So that'll be hollow. So I need to get rid of that. Let's do some save. And just have a look at the, yeah, let's stick through, okay. Let's give it some depth now. 1.6 mil is the PCB thickness. Okay, so the top PCB, so PCB, that's the old PCB. We'll leave that one there for a minute for reference. So let's top PCB. Okay, we'll put it on the top PCB layer. I don't know, there's only one PCB there. Top PCB. Oh, we've got something left over here. What have we got left? Why have we got what have we got? If I delete them, what happens? Are these glitches left over? What are these? There's something. What are they? Can't select. Like faces. That's weird. Right, that's strange. Okay, so I don't know what's going on there. View. View. X-ray. So hide the top. Yeah, we've got some weird stuff going on here. I don't know. Don't know. Don't understand that. It's probably a glitch. Right, so software glitch, maybe. Tell you what, let's move the PCB. Oh, I know what I've done. I've put it in. I haven't grouped it as a PCB. Make a component. That's why. Right. I've still got that there. Can we delete it? No. Right, let's move the thing then. So we've moved it and we're done. They're following it. That's just a glitch, isn't it? So undo move. Okay. Alright. So, is it a glitch? So the only way of knowing is to close. What's happened to my layers here? Oh, we're scrolling off the screen. Right. Okay. Let's put the clam back. Not that one. At the bottom. So we're too exact in the size, so we need to pull back slightly. Let's pull back on the PCB. Perhaps I should have done that before I made it thicker. Right, we can do it. There's ways of doing it. What did that do? No, I don't want that. Right, I want that, so it's needs to be only half a mil less, 0.5 of a mil. Right, then we need to shrink it down to nothing. Okay, and then we need another one here. No, not there. Go on. Where is it? It's not like it, is it? Go on. Right, here we go. Oh, it doesn't like that, so what we'll do is we'll take a bar out of it for a minute, put a bar back in. Yeah, and then we've got a fill, and we should be able to do 0.5 of a mil and delete the old one. So we're overlapping the shelf by only 1 millimeter. Sorry, 0.5 of a millimeter. 0.5 of a millimeter. Right, we've got all sorts of bits going on here. So, is it going to let us extrude it to there? It will, but we've got some rubbish going on here. Oh, we've messed that up big style. Okay. Oh my god. Messed that up. We've done it in the wrong sequence, really. Alright, let's do it in the right sequence. You have to do things in a certain way. Undo offset. Right, why have we got no bottom to it? Undo an offset. Undo a draw line. Undo a flat script. I didn't do a flat. Undo a raise. Undo a push pull. Right. Okay. Okay. So we've got our we've got our back. We push pulled and we lost our bottom for some reason. Let's try again. Have we lost our bottom? Yeah, we lost our bottom. We don't want to lose the bottom. So, right, we need to do this in a different way. Undo offset. flatten it. Can we do undo, open, undo? No. Redo, open. Go down to, if I go down to nothing, it'll disappear, won't it? Yeah. No, I don't want to do that. Right. We've got a bit of a weird problem there. Shit! You have to drag it kicking and screaming. Free software, drag it kicking and screaming. Pay a lot of money, get some better software, learn how to use it, and you're tied in for life. Anyway. Right, so we're close, but with something not right. I'll tell you what we'll do. I can get this back if I go like that. Go into that and literally just delete the top bit. Then we get left with all these little bits sticking up, which we've got to delete. Delete all these. Can I do it like that? No. I have to do them manually. Laborious. Laborious. But possible. Laborious but possible. This is what makes it take so long to do anything. Yeah. I've got a way of working, making it do stuff that works, but it's not ideal. It's not the best way or the easiest, but you slowly get results. Right, so we need to make this the right size before we start doing anything. That was a mistake. Get this cleaned up before we do anything. And you've got to remember, nested, where you got to and which parts you need to move. Not easy if you've done some undoing, because you've got to remember what you've undone to redo later. Alright, this is terrible. Is there not an easier way? No. Is it easy to undo them? Yeah. Probably easy to undo those bits. If you can, when they get tiny. Delete them like that. It'd be nice to have a clean up script. Clean up script. Clean my thing up. It'll probably clean it up in the wrong way. Right, here we go. Okay, what's next? These few. Ah, dear, dear, dear. Anyway. It's an illness, you know. Not going down the pub, spending hours on such a thing. It's definitely an illness. Right, so what have we got now? We've got a flat object, yeah. So I'll come out of that and save it. It's too big. So we need to, let's just make sure it is too big. Yeah, it's the exact size. We don't want a PCB the exact size. Needs to be needs to be smaller by, it won't let me do an offset, will it? Oh, it will if I go in, maybe. Yeah, needs to be smaller by point. Tell you what, leave that bit for a minute. Let's try to make this one's not quite right. Well, that's exact size, so it needs to be smaller. So we need to somehow make this bit won't attach itself to that bit, will it? Right, so I need to do that bit again. Come on. Take that out. And then put it back. And then relief it by 0.5 of a mil. And then delete this. So why is it half of it in sections and half of it joined? No, don't want to do that. No, don't do that. Stop it. Keep the concentration level high. That's the problem with this. Okay. So we've got our relief, so we can get rid of that now. And we should have some step back on it. Relief. Yeah. Now we've got to do the outer bit. No, not that bit. Right, so we've got to do... No, not that bit. Yeah, 0.5. There we go. So now we've got to delete. Why have we got too much going on here? We've got to delete all that bit now. Okay, here we go again. Why has it done that? Oh my god, it's trying to send me mental, isn't it? And the worst thing is I've got to make a PCB out of this yet. The same shape. So it drops in. It's also it's PCB, it's aesthetics. It's aesthetics as well. So it's black PCB and it's got to keep being a bit dark. So it's it's a piece of internal livery that stops the buttons from well, looking through into the box from outside. Stops you seeing loads of wires, electronics sort of thing. Keeps it all dark. Better for the illumination maybe, yeah. Better for the neopixels to light up and all that kind of stuff. Neater, keeps it neat. Supposedly. Whenever you start a project like this, it just goes wild. Exponentially crazy amounts of work time. How long we spent on it? We must have spent about 9 or 12 hours on it so far. Got her done. Plus what we're doing today. 2.5 hours a time. We're up to 4. So say 10, 11 hours. Right, nearly there. And the PCB house is not gonna like me if they've got to mill this out. I could mill it out myself after, just get it made square and then, but why bother if they can do it. Right, so we've got a half piece of flat PCB now that sits in on a shelf, holds it level. Right, okay, so now we need to, and it hides the cable. Let's just make it the right thickness. Let's do that now. Right, do we do the thickness first and then pull back? So 1.6 mil PCB, give it some strength. Let's colour it. So we want a pullback on it now. So another pullback, 0.5 of a mil, and we're back to this bit where we can't pull that back anymore. So we'll have to, we're going to go through the same process all again. Tell you what, let's go back a couple of stages. Can we do it while it's flat? It is flat, isn't it? Yeah. Can we do this while it's flat? 0.5 of a mil, or was it 1 mil? Let's say 1 mil. One millimeter, and we need to just draw that there. Pull that back by 1 millimeter. I'm not going to take it out, we're just going to use it for colouring. Can I see both sides? Don't know. Right, let's make the thickness right. Let's see if we can still, is this going to hollow it out maybe? 1.6 mil. What's it done underneath? Made a big hollow? Yeah, that's no good. If you do one thing to try to help you, then you come across another problem. So, yeah. Okay. Right, so we've got our PCB. Let's make it the right thickness. 1.6 mil. Let's have a pullback on it. 1 mil. We're going to have the same pullback the other side. 1 mil. Right, we've got our two colours, we've got our thickness. We're going to have to take off that and fill it, and then come back off it 1 mil. Yep. Then we're going to have to take that off, go back to the other side, go back to the other side, take that off it, put it back, and bring it back by 1 mil, and take that out. So now we got ready for the colouring. So black PCB, so you want a synthetic surface, that one. Synthetic surface, and now we want nice gold colour. Colours. Golden colour, which one was it? So that one. That be okay? Yeah, probably be okay. Bit bright. Let's go a bit less. That's better. Yeah. Right, yeah. Okay, and the rest can be it'll be black, won't it, I suppose? Does it matter? Yeah, it matters. Synthetic surfaces. Do I really want to do all that? Not really, no, I'm not going to do it. I'm going to leave it. Okay. So we've got our PCB. What's the average size we can work with? 9 point something mil. We've got a bit of space for doing something. Right, let's save that and put back the put back the bottom, top. Where's my bottom clamshell suddenly decided to go move position? Weird. Right, so we've got our PCB that sits in. It also hides our cable. The cable comes up at the bottom, into here, down. And so your PCB can be dropped into it. Now, does it need to fasten the PCB? No, because you need to get behind it. So you need to get behind it to put your screws in. So you need to put your PCB in yourself. So, why have I got all these lines? What is going on there? What's that? What is that? What view am I in here? Hey. Bottom clamshell. Right. That's weird. What on earth? Top PCB. What the hell? Hey. Is this a glitch? Right, let's just delete. Can I delete that? Delete. Right, top PCB. Ah, got nothing there now. Undo. 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 Oh no, where's it gone? Bloody hell. Thought I'd lost it then. What the hell? There's some weird shit going on here. You can't select the whole line. Terrifactor. Hello, Terrifactor. Must be pre-recorded. No, it's not pre-recorded. I'm just not paying attention, sorry. Hi. At 3 vector. Yeah. You can't select the whole line, right? Yeah, I don't know what I've done here. Let's have a look. Something gone wrong here. What the hell? What is this? So, I've coloured something. I think there's a glitch. Why is there a piece of white surface there? So if I don't do it, right, I need to put it onto the same. So I'm on there. I can't select the whole line. Right. Explode. So do I explode it? And then hide it? No. I'll put it all. Doesn't know what layer it is. So layer, PCB, top. And make it a component. Right. No, still got some bits. Oh, the original bits that. Some weird stuff going on. Look at this. Right, I think I'm going to close the program down. Am I an engineer? I'm an engineer, but not for this. Industrial door and automation. That's what I do. If you ask a locomotive engineer, am I an engineer? They'd laugh. But yeah, no. Yeah, I'll just dabble with creating stuff. I want to create, mess around with access control, and I'm trying to do a button, an alternative design to a button, a 4-way button with neopixels that you don't select, you don't type numbers in, necessarily you do colours or you respond to flashes. A bit of a weird one, different type of button. Right, so I'm gonna save this. I'm gonna close this down because I don't know what's going on, and I'll load it again. I think it'll probably be exactly the same. Right, so I'm going to load this up again. Yeah, I've got one of the Chinese CNC 6040s, and it will mill out aluminium if I mill it out, say 0.25 of a mil each pass, so multi-pass. Right, let's get it back. So it's still there. I thought it might be. Right, top PCB. So I don't quite know what's going on there. Yeah, I'm using a free version of SketchUp Make 2017. There's better versions out, but I don't want to pay. I don't want to pay. I don't want to sign up to some subscription model. Not into any of that. Anyway, let's. What is going on here? So if I turn that off, what about that layer? If I switch to top PCB layer, switch off. I can't switch off that because it's the current layer, so I can turn that layer off. So if I switch to another layer and turn, it's not even there. So layer 0. So I'm on layer 0. Why am I on layer 0? That's weird. Right, so let's turn that off. I need to be, so if you turn that off, that is strange. Right, I'll tell you what, I'm going to put it all back to layer 0. It's in layer 0 already. That's weird. There's something weird going on here. Right. So I'll turn off that. Yeah, that's it. It's all gone now. You cannot hide the component. Right. Okay, so I think we've cleaned it up. Yeah, it's gone now. It's cleaned up. Some weird glitching. Anyway. Right. Let's put the PCB back. The bottom clamshell. Right, so this PCB is going to drop into this box. So we've got this bottom piece of aluminium, 15mm thick. It's going to be milled out. Your cable comes through here. Your fixings to hold it to a post or brick wall, whatever you want to. It's got to hold it to really a post. We've got a shelf for the PCB to sit on around there, and we've got, so you put your PCB in. Then we've got our tactile button, neopixel. Then we've got our top polycarbonate plastic. It sits over the button, and the polycarbonate plastic is 0.6 of a mil above the metalwork. It's being held up by the tactile button. Might have to have a spring on here, depends on how good the milling is. It's got to be free flowing. Might need a strong click tactile button or a different kind of button. The idea is the frame, the top clamshell, holds it in position, level sort of thing. Press your button in, and as you press your button in, you can't crush the button itself because your button plastic push polycarbonate will bottom out onto the metal. So you can't vandalise it by over pushing the button. We can make the button colour whatever we want. So the rest of the buttons, fixings. Right, so yeah, the idea it sits on the wall like that. Hang on, like that, and all you can see is a dark PCB and maybe some metal work. And you can push any button and they light up. They pre-light up, or they can light up whatever you do with your programming, with your Arduino or your ESP32, any microcontroller, what you want to control your neopixels and button inputs from. The idea of this, it's secure. There's no relay or no way. It controls whatever you want to control. Can be a request to gain access to something, whatever it needs to be. Could be anything really. There's no output control from here. It sends data. Data from here gets sent to probably RS485 data, something similar. I2C, it can't do I2C too far away. So I think it's 500 mil really. But the idea is, if you did manage to get this open, you can't circumvent the system by shorting out wires this end. It's got to be a digital signal that gets sent over to another PCB or the main PCB. Depends how much space there is. Because it's aluminium, if it was wireless Wi-Fi, it might block out the signal, even though you've got some clear polycarbonate. So the idea is for security and for making the wireless work out of the metal, the remote PCB. So it's going to be something like a CAN bus, that kind of thing. So there'll be some ICs here, very minimal amount underneath. The ICs will sit underneath the PCB. So we'll have the buttons and neopixels on top. There might be a few resistors and stuff, I don't know. Or maybe I'll just keep it clean. So underneath here is where we put the ICs and wire the connector. So the wire will come through, and I'll have some solder pads. Let's just solder it in an array like a Christmas tree. There won't be many wires. One for power, one for ground, and probably CAN bus. So it might be 4 wires, maybe 4 wires. Ground can be shared for like an RS485 half duplex kind of thing. Don't know. Might try CAN bus for a change. Do RS485 already. Right, so yeah, it will actually fit. So it's got to be able to drop in. So you drop this into the base. Now the only other question is we've got to sort this out. So I've got rid of the holes in the bottom. So I've got to re-put the holes back in. Let's do that next. So hide the PCB. If I can find it, it's moved it. Right, so the cable comes in here. So you drop your board into it. But then you need to get to your fixings to mount it to a pillar, a wall, or a post, metal post. And the PCB is blocking those holes initially. Unless the lid unless these screws go straight through here into the pillar. It's tempting, but then it'll make it fiddly to assemble. So you'd have to put, you need to attach this to the wall so you can, but it's pre-wired anyway. It's pre-wired anyway, so do you need to get to it? You don't need to get to it to gland it, to screw the wires to the PCB. They're soldered anyway on a flying lead. So could these go straight through? So the only reason you take the top clamshell off, you'd line it up, drill your holes, tap them. These bolts could go straight through, I suppose. You could lose those holes. That might be better for a water ingress problem. Yeah, that could work. Because the whole idea of being able to take this lid off is to screw it down and screw the wires to the terminals, but if they're going to be soldered anyway, so you could just as well keep this together, the top and bottom clam, and just drill and tap those straight through. So the pins come long enough. Yeah, that would work. That would work. So effectively the PCB could be dropped in, and so you just buy it or make it ready, drop it in, yeah. So we could go. I'm thinking, is there any advantage? Did you want to put this on the wall or on the post as quick as possible? You don't want to be fiddling around with it. So you want, do we need these holes? No, probably not. Just fix it through them holes. But how do you hold this on the post? So you hold that base on the post, you pilot it with a drill through these holes, use that as a template. Take it off, drill and tap your holes on the post, put it back on, tuck your wire through, so you drill a hole for your wire on the post. I suppose we could draw a post. Don't want to draw a post really. Draw a 60mm post, square post, bolt it to it, drill your hole. So what holds that up? Well, you've already templated it, use the base as a template, you drilled and tapped them, so the only reason you'd have the PCB out is to get to these holes, but if we didn't need those holes, the PCB would be already in. So what you'd have to drill on your post, you'd have to have your post, you have to drill your hole for your gland your hole for your cable. You'd have to put your cable in the post or on the metal work beforehand, mark these out, drill them, and then just this. You wouldn't need, if you didn't need to have the holes, you wouldn't even need to take the buttons out. You wouldn't need to take it would just be like that, wouldn't it? But this would, yeah, you'd need to take the lid off. So this would be part of the lid, basically. Yeah. So they'd be with the lid. So I suppose you could, these are flush with the lid anyway, and once they're in, but you don't want bits falling over the floor, so I suppose you could put a protective sheet, like just like a polythene sheet that protects the surface of this and sticks the polycarbonate to it, so it contains it. And once you finish, then you take it off. And then that could also contain the screws as well. So your sheet contains those and the screws, keeps them all together. So that you wouldn't see that would be on the top piece. So all you'd see is the PCB. Hold it up, use that as a template, take it off temporary, yeah, drill it. Okay, I think I'll go with that idea. Slightly less steps. Because if you buy an RFID reader, it comes potted anyway. You don't necessarily, you use the... And it could come all together, couldn't it? Yeah, you could just get it like... It could be fastened together anyway. So what about if two screws fasten the clam together and the other two go straight through? Is two enough to hold it to a post? Probably. So two go straight through and the other two are just milling halfway. That holds that. It's a contained unit, and you can still undo it to work on it if you wanted to. Yeah, you need to be able to open it, maybe. Alternatively, the screw holes come from the back, screw to the lid, so you don't see the holes, but you still need to mount it. So yeah, don't know. This version I think will keep as it is, so you can mount it all the way through. Alright, okay, so let's see where we got to. Alright, so we've got that. So I don't think we need the back holes on it, so let's get rid of the back holes. Right, let's just get rid of these holes then, we don't need them. Don't need these holes after all. Okay, let's make sure we've got rid of them all. No, we didn't get rid of them all. Didn't quite get rid of them all. Okay, so now we need to push the holes for the fixings. Oh, look what I've done. See that? You got to do it from the outset. Right, let's try again. Make sure we don't get nothing. Change the angle. Make sure we don't pick anything up. Don't want to select anything else by mistake. Right, have we done? Yeah, we're okay that time. So the only hole in here is this one here. That's the only hole. That's in the middle. So you'd have to gland it and connect it to the PCB. So be it. Tight fit, so it could be sealed in. And we need a drain hole probably, just in case. Right, so now we need to put the fixings. I need to create holes now in this. and this part of it can go. Let's hide the fixings we need it there, so let's get rid of this bit here. Some of this, get rid of this. Okay. Oh, we still got, let's get X-ray mode up. We've got a bit of structure there. Needs to go. Need to get rid of that bit of structure. Is that one there? Can't tell. No, that's not it. It's that one there. Right, have we cleaned it up? Yeah. Oh, we've still got something going on there. This bit needs to go as well. Good thing about X-ray mode, you can get inside the steelwork. Right, one more. Okay, so have we got rid of it? Yeah. Anything else that needs to be got rid of? I don't think so. Right. Okay, let's do some saving. So we've got rid of our holes, we've still got our glanding hole for the cable. We need to create our fixing holes now, so they need to go straight through there. So the easiest way of doing this is just to turn off the cam, the bottom clam, grab hold of that. Can I get them all? I don't know if I can get them all. Can I select them all? Not sure. Tell you what, let's grab them all. Copy. Can I do paste in place? No. Undo. Right. These are components, aren't they? Right, so I'll have to copy one at a time probably. Paste in place. Bottom clamshell. Right. Let's move it out by 15. I'll put the clamshell back. It's long-winded. I could just do that and then drop it onto the surface of the component, on the face of the component. That's it. Right, we need to do that a few more times. This ensures everything's in exactly the right place. I suppose we could measure that from there to there. 4 mil. Just take that up 4 mil. Okay. Next one. Copy. Paste in place. Move it up 4 mil. And again. Copy. Paste in place. 4 mil. Right, so we've got them all on 4 mil. So turn off the fixings, turn on the bottom. Right, so they're all there. Now we've got to push them through to the bottom. Okay, we've got to grab them first, cut them, paste them in place, and then we should be able to, yeah, push them through. Push them through to the bottom. Needs to go right through to that. Maybe to have a look at that. Yeah, there they are. Same with the rest. All the way to the bottom. All the way to the bottom. All the way to the bottom. Yeah. So we've got them back again. That's good. So put the top clam on. And that should all line up. If you go like this in parallel projection, everything lines up. Yeah, everything lines up. So we're going to go straight through with our 4 fixings. So our fixings need to be longer. So we've got, let's measure depth, what we've got here so far. 25mm. View X-ray mode. Our fixings, they need to come out and at least stick it into the steelwork 5mm. So what we'll do is we'll grab the fixing. Oh, we can see what the difference is. I think it was 4mm, wasn't it? It was 4mm from our last thing. So what we can do is go back to that, just look at our fixings. Just grab one of them because they're a component. Extend it by, it was 4mm down, it needs to stick out 5mm, so it needs to be 9mm deeper. Right, okay, put the bottom clamshell on. We should be sticking out 5mm. Yeah, that's it. Okay, so that's it. So the fixings go straight through. Yeah, good, 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 good. Right, okay. Have I got somewhere now? Let's have a look at the take the lid off. The cable come through there. A 5mm cable. It would come down here and solder to the PCB, which is that. Yeah, it's always a bit too much, that view. Right, so it tells us, I suppose we could make the PCB semi-transparent like the button so we can see what's going on. But I won't though. Right, so we can put the buttons in. So neopixels next. We've only got the one, and we've got, let's move. Let's move these buttons onto the tactile button layer. Tactile buttons. Okay. Right, let's put the buttons ×3 onto the buttons layer. Okay. So let's enable the buttons layer. Right. So we don't need buttons ×3 layer no more. so we can get rid of that. PCB layer, it's not being used. Oh, there's something there. Oh, that's the old PCB. Yeah, we don't no longer need the old PCB. So we can get rid of that. Let's delete the old PCB. How do you delete it? Just like that. And get rid of this old PCB. Right, so we're okay now. Everything we've got is what we want. So tactile buttons, neopixels. We need more neopixels. Fixings we can get rid of in a minute. Bottom and top. And you've got your buttons. Right, okay. So we need some more neopixels. Right, we need to place our neopixels. So which is that's our right way up. Yeah, that's it. So we've got to work out where we're going to put these neopixels now. So doesn't really matter, I suppose, wherever you can get them. That could be lowered, couldn't it? Right, hang on. Let's bring that down a bit. It's over there. Somewhere like that, maybe. Level the button. Right, so we come down 0.5 of a mil. Right, let's copy it. It needs to be this side of the button. We need 2 more of them. Oops. Something like that. That's okay, but it needs to go. Those 2 need to go up a little bit. 0.5, yeah. Okay, what's it like? Have we gone? No, we're okay. We're on the circuit board. Right, so we've got to make a circuit board. This is buttons and 4 buttons and 4 neopixels. It's not a circuit. So underneath will be some ICs and some pads to wire your cable to it. We've been going for 2 hours. I don't think that's enough. No, probably don't think we've been going quite 2 hours. Started this stream and didn't go live for a while, so right. Anyway, let's put it all back together. And it just looks exactly the same as when we started, but no, it isn't. So, is there anything left to do? Obviously, I'm not going to draw all the other bits and chips and stuff on there. I could do if I wanted to model it better. Well, the next thing is to create this outline as a PCB. We're using Keypad. Used to use Eagle for such things, but Keypad now. So we're using Keypad. I've got one of my previous PCBs done in Keypad, so neopixels, any colour button you want. Polycarbonate, a shine through. This mounts, yeah, so we've got to build one. Now, are we at this stage? We could mill out the shell. We've got to find some materials next. Anyway, that is going to be it for today. I might as well capture that now and get the next. Now I'll leave all that for later. Right, that's going to be it for today. So I'll close that. So this is number 4 in the series, the meat and potatoes, the keypad. Totally changed now. Next thumbnail will include all the additions. Well, I'll see you on the next one. Thanks for watching and have a good day. Bye bye.